Okay, now let's look at question number 9. Okay, I have a triangle here, ABC, which cuts the point C lies on the x-axis over here, and point X lies on the y-axis. And we say that we are given the equation of line CX, and AB is perpendicular to the line CX. Find the equation of line AB. So very simply, if I know that this line is perpendicular to this line, we know that the gradient multiplied of these two lines together, it will be -1. So from here we can see that gradient of line CX. From this equation here, we can see that from the form y equals to mx plus c, gradient is equal to half. Therefore, this means that gradient of line AB is equal to -2. Okay, and therefore I know that based on y equals mx plus c, the y-intercept is -2, which means x here, this value is -2. Therefore, for line AB, I know the gradient is -2, y-intercept is -2. So therefore, very simply, equation of line AB is equal to y equals to -2x minus 2. Okay, this is for part A. Alright. Okay, next part. Given that the y-coordinates of A and B are 4 and -4 respectively, so I'm given that over here, this is -4, A here, this value here is 4. Okay, find the ratio of AX to XB. So very simply, let me highlight this part here. Okay, AX is this line over here, XB is this part of the line that's over here. Okay, I know that you can easily see, actually this is a similar triangles concept. Okay, if I were to highlight this triangle here in blue compared to this small triangle over here, okay, you can see that these two are similar triangles. This length here is 6 units. This length here is 2 units. So very simply, the length of this big triangle over the small triangle, AX to XB, is simply equals to 6 units to 2 units, which is equal to 3:1. This is for part B. Okay, part C. Find the coordinates of B. Okay, so over here, if we look at the diagram here, B has a y-coordinate of -4. Okay, so over here, since B lies on the line AB, very simply, sub x, not x, but sub y equals to -4 into equation of line AB. So very simply, -4 equals to -2x minus 2. I'll get x equals to 1. Answer the question, therefore, coordinates of B is 1, -4. Okay, this is for part C. Okay, next one. Given that BCXD is a parallelogram, find the coordinates of D. Okay, so let's look at the diagram here. BCXD. So for BCXD, this means that, let me erase this part here. Okay, for BCXD to be a parallelogram, it means point D must lie somewhere over, point D must lie somewhere like this in order for, why my diagram is not showing. Okay, let me try to draw this properly. Okay. Okay, something like this, let's estimate. Okay. Oops, that's not the best parallelogram. Wait, let me duplicate this. Paste. Okay. So, oops. Okay, so you can roughly see, I'm just doing this so that you can visualize what I'm talking about. Point D should lie somewhere around here. Okay, where is point D? Okay, so over here, very simply, how do we find coordinates of point D? I know that point B has the coordinates over here, 1, -4. Point C has the coordinates. How to find coordinates of point C? Very simply, this is your x-intercept. So from here, maybe we can write down here, when y is equal to 0, for the equation of line AB, not equation of the line CX, okay, when y is equal to 0, okay, half x minus 2 is equal to 0. This means x equals to 4. Okay, so therefore coordinates of C is 4, 0. Okay, so I know that over here, this is 4, 0. Okay, and coordinates of x, this is this is 0, 0, -2. Okay, so to find parallelogram, you can simply do by counting. We know that parallelogram from these two edges here, the horizontal and vertical change must be the same. So I can easily determine over here. Okay, you can see that this distance here is 4 units. This distance here is 3 units. So therefore, by counting, we know that from x to d, the horizontal change must be the same as the vertical change. So over here should be 4 units. To the left, it should be 3 units. So very simply for part D, okay, therefore, coordinates of D, I take the coordinates of x coordinate 0, I'll go to the left by 3 units. So this will be 0 minus 3. And for the y coordinate, I'll go down by 4 units. So to here is -2 minus away 4. Okay, -2 minus 4. Simplify your answer, you should get -3, -6. Okay, this is for part D. Alright, and the last part E. Find the area of triangle ABC. I know that A is given by this coordinate -3, 4. B is given by the coordinate 1, -4. C is given by the coordinate 4, 0. Okay, so to find area of triangle ABC, I look at the diagram. ABC is this triangle over here. We can use the shoelace method. Shoelace method means I just need the coordinates and I go in the anti-clockwise direction. Okay, so I go A, B, C, I go back to A in the anti-clockwise direction. Okay, so very simply, if I apply the shoelace method over here, okay, therefore, area of triangle ABC is equal to half. Then I write the coordinates in anti-clockwise direction. Coordinates of A, B, C, then I go back to A again. Okay, then now I can apply the shoelace method. So this will be -3 times -4, multiply downwards in this direction. I'll get 12 plus 0 plus 16 minus away. Now I go in the other direction. Okay, which will be minus away 4 minus 16 plus 0. Okay, so this will be, simplify, half times 28 minus away -12. Okay, calculate in your calculator, you will get 20. Remember, area, this should be a unit square. Okay, and this is for part E. Alright. Okay, let's now look at question number 10. Okay, shows experimental values of x and y. Related by this equation here, plot log y against x. So in order to plot log y, we must calculate accurately. So you need to have a table of values over here. Okay, I want to find log y. Okay, so that means that based on this values in the table provided, we have to calculate what is the values of log y. Okay, so over here, very simply, I will draw, make sure you draw very clearly so that the marker can see your table of values. This is also worth 1 mark when you calculate correctly. I want to find log y. So first one, log 2.29. Okay, let me calculate this. Okay, log 2.29. Okay, I will get 0.35984. Okay, good to write this as 5SF. Okay, more accurate the better. Okay, 0.5984. Next one. Log 4.62. I'll get 0.66464. Okay, next one. 9.38. I get 0.97220. And the last one, 19.1. I get 1.2810. Okay, so over here, I can plot log y against log x by first plotting the points correctly. Okay, your point should look something like this. Okay, x is 1, y is somewhere here. Okay, 2, 3. Okay, my points may not be the most accurate because I'm using my iPad, so it's a bit hard to get the accurate values. 3, 5 somewhere here. 5, 1 looks. Sorry, this one is somewhere around 3. Okay, 5 is somewhere around here. Okay, 7, somewhere around 1.3. Okay, 1.3. Okay, so if I draw a straight line, your graph should cut through thing like this. Okay. Okay, so your graph should look something like this. Once we draw a graph, okay, make sure your points are labeled correctly. So this is your graph that you should obtain. Okay, then the next part of the question, use your graph to estimate the value of the constants a and b. So we know that this graph, actually we are drawing a straight line graph obtained from this equation, y equals to ab power x minus 1. Okay, so we convert this into a linear form by taking log on both sides. So I'll get log y equals to log ab power x minus 1. Then I separate by my product rule, log a plus log b power x minus 1. This is log y. So therefore, log y is equal to x minus 1 times log b by power law plus log a. This will be x log b minus log b plus log a. Okay, so therefore this is my straight line graph, y equals to mx plus c. So maybe I can simplify this. You can see in my linear form here, my y-axis is log y, my x-axis is x, so means gradient is log b, my vertical intercept will be log a minus log b. Okay, so very simply, this means that gradient of the graph, you can choose 2 points on the graph. Okay, so I'm just using an estimate based on my graph that I have. Okay, this means gradient is equal to log b. Okay, the big y-intercept, or we call this the log y-intercept, is equal to log a minus log b, which is the same as log a over b. Okay, so gradient, this is an estimate based on my values here. You should get, in this case over here, take 2 points on your graph, draw your big triangle, then you can calculate the gradient of this straight line. Okay, it should be 0.153 plus minus 0.01. Okay, so therefore over here this means that log b is equal to 0.153. Therefore b is equal to 10 power 0.153, which will give us about 1.42. Okay, likewise my vertical intercept, I get log y, log a over b will be equals to, based on my graph here, my vertical intercept is 0.2. So therefore this is equal to 0.2. So this means that a over b is equal to 10 power 0.2. Okay, and since I found out from my first part over here, b is 1.42, therefore is equal to 1.42 times 10 power 0.2, which will give me 2.25. Okay, so this is your answer for question this question 10 part B. Okay, let's now look at question number 11. For question number 11, I'm given another linear law question. I plot x, y against 1 over root x. Express y in terms of x. So from here, okay, I know that, okay, right, xy is equal to m times 1 over root x, the whole thing plus c. Okay, so this is the straight line graph I'm actually drawing because this is my y-axis. I don't know what's the gradient. This is my x-axis. This is plus c, the vertical intercept, which is not seen over here. Okay, so I know that since 1, 4 lies on this graph here, I can sub 1, 4 into equation. And take note, 1 over here, this is my x coordinate, but this is not the small x. This is actually 1 over root x. And this value represents xy. So this means that 4 is equal to m times 1 plus c. So therefore, 4 is equal to m plus c. Okay. Likewise, since another point that lies on this graph as seen from this equation here is 5, 10. So therefore, I can sub 5, 10 into the equation of this line as well. These values satisfy this equation again. Okay, so when the 1 over root x is 5, xy is equal to 10. So 10 is equal to 5m plus c. Okay, so therefore you can now easily solve this by simultaneous equation since I have two equations now. Okay, I get c is equal to 4 minus m, c is equal to 10 minus 5m. Okay, therefore, by solving this, okay, therefore, maybe make this a bit smaller. Okay, so this means that 4 minus m is equal to 10 minus 5m. Therefore, 4m equals to 6, m is equal to 3 over 2. And this means that c is equal to 4 minus 3 over 2, which gives us 5 over 2. So therefore, to express y in terms of x, I have found m and c. So this means that over here, xy, why is it like that? Okay, over here I found xy is equal to 3 over 2 times 1 over root x plus 5 over 2. Okay, and the question here express y in terms of x, so I must make y the subject. This means that, therefore, y is equal to 3 over 2x root x plus 5 over 2x. And there's your answer to question part A. Alright. Part B. Given that at k, 40 lies on this line, find the value of k. So very simply, I just need to sub the value k, 40 into the equation. Okay. I know that over here, I sub into this equation over here. So when xy is equal to 40, I know that m is 3 over 2. I want the 1 over root x is equal to k. Okay, plus 5 over 2. So from here, I simply just need to find the value of k. 3 over 2k is equal to 40 minus 5 over 2. So therefore, k is equal to 40 minus 5 over 2 divided by 3 over 2. Your answer will be 25. Okay, and this is your answer for question 11 part B. Alright. Okay, let's now look at question 12. Question 12 over here. A pendulum is released from rest at position 1. Then it swings down and go back to position number 2 after losing energy. Okay, and it is released at an angle of 2 theta. Then they say that after one complete oscillation, which means that it goes from position 1 to position number 2, okay, the angle of the vertical is half. Angle of the pendulum from the vertical is half, which means that this angle here becomes theta. Okay. Show that the difference in the vertical displacement of the pendulum is this expression over here. So that means that over here, in this there's a new height over here. Let's call this the second height, and we call this height here h. Okay, so if I were to look at the first triangle, we can see a right angled triangle here. Okay, I know that since the length of the string is 15 cm, this is also 15. Okay, therefore in this first triangle, I can form based on my tuaka so, right angled triangle, cosine theta is equal to adjacent, which is height h over 15. So h is equal to 15 cosine theta. Okay. In the other triangle now, let's look at the other triangle I can form. Other right angled triangle is this green color right angled triangle over here. Okay, oops. In this green color triangle over here, you can see that I can also form, based on my right angled triangle, another Toakasu relation. Okay, cosine 2 theta. This angle over here is equal to the adjacent y over 15. Y over 15. Okay, so this means that y is equal to 15 cosine 2 theta. Okay, so that means, right, from here I can continue to simplify. Actually, I know that cosine 2 theta, right, I want to use cosine 2 theta to find out what is cosine theta. Okay, so over here, you can use my double angle formula actually. So actually, if I use a double angle, you can turn this into 2 cosine square theta minus 1 equals to y over 15. Okay, this means that 2 cosine square theta is equal to y over 15 plus 1. Okay, therefore, cosine square theta is equal to y plus 15 over 30. Okay, therefore, this means that cosine theta is equal to square root of y plus 15 over 30, but this will be a plus minus square root. But since we know that this angle here must be acute, by ASTC, for this theta to be acute, cosine must be positive, cannot be negative. So therefore, we have to reject negative square root y plus 15 over 30 as theta is acute. Okay, so this means that cosine theta is given by this value over here. Okay, the question is, show that the difference in vertical displacement. So show that this difference here is this expression. So therefore, difference in vertical displacement. Okay. Okay, so maybe let me make everything else smaller, huh? Okay, over here I will reduce the size of this. Okay. Okay, so over here, the difference in the vertical displacement is simply equals to h minus y. Okay, and I know that h is given by 15 cosine theta minus y, and therefore cosine theta is given by positive root of this, which will be 15 times square root of y plus 15 over 30 minus y. And therefore, we have shown what the question wants us to show. Okay, and this is shown. This is for question number 12. Alright. Next, let's move on to question number 13. Okay, question number 13. Express in terms of pi the principal value of this. Remember, principal value means what is the value a calculator will give you when you press in your calculator. So if you press this value in the calculator, you will actually get, in this case here, 45 degrees. Okay, and for 45 degrees, this can be represented to be pi over 4. Okay. Next part. Part B. Without a calculator, find cosine 105 degrees. If the question says without calculator, you must identify special angles you can use. As we know, cosine 105 degrees can be written as cosine 60 degrees plus 45 degree. Okay. Therefore, by using your cosine addition formula, you can get cosine 60 degree times cosine 45 degree minus away sine 60 degree times sine 45 degree. Okay, sub in your special angles which you should have memorized. You will get half times 1 over root 2 minus away, okay, minus away 1 over root 2 times root 3 over 2. Okay, it should be, well, it should be swapped. It should be swapped in this case. Okay, so over here, simplify everything. It will be 1 over 2 root 2 minus away root 3 over 2 root 2, which will give you 1 minus root 3 over 2 root 2, which, remember, final answer must rationalize. There should be no cert in the denominator. So multiply this fraction by root 2 over root 2. Your final answer should be root 2 minus root 6 over 4. Okay, this is for part B. For part C, for this interval here, sketch on the same diagram this graph and this graph. Okay, this is your standard trigo graph. The steps are always the same. Identify the shape first. Shape is a positive cosine graph. Okay, period is 2 pi divided by 3. Okay, so therefore in this case here, from negative 2 pi over 3 to 2 pi over 3, I have to draw 2 cycles. Okay, axis is y equals to negative 1. So therefore max y value, okay, is equal to y equals to, the amplitude is 2. So we add 2 to your maximum, your axis here. This will be 1. Minimum y value, okay, will be negative 1 plus minus 2, which will be y equals to negative 3. Alright, so with all this important information here, we can now sketch this graph. Okay, let me make this smaller. Okay, so we can now sketch this graph over here. I use this line here. Okay, okay, so remember, when I sketch the graph, I always mark my middle line for the cosine graph first, which is negative 1. Okay, and then I mark the maximum value 1 and the minimum value 3, negative 3. Okay, so this means that my x-axis lies somewhere here in this line. Okay, maybe I need to draw so long. Let's draw like this. Okay, okay, this is my x-axis. Okay, then from here, I can then mark the period 2 pi over 3. This is one cycle. The graph is until 2 pi over 3. Okay, so I can split this into 4 quadrants. Remember, one period split into 4 parts. 3, 4. This is 2 pi, pi over 3, pi over 6. Okay. Okay, over here, it will be, okay. Okay, so once we can split this into these parts over here, okay, okay, then we can then draw my dotted lines. Okay, remember, dotted lines are important to help us visualize how the whole diagram will look like. And because this graph asks us to draw up to the negative portion as well, we must also have the negative part here. Okay, negative 2 pi over 3. Okay, negative pi over 3. Okay, so you can split your graph to look. Okay. Okay, my graph is a bit harder to draw on my iPad, so you should have much more accurate lines on your own paper. Okay. 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 Okay, here. Okay, so your graph should look something like this, okay? I try my best to draw as nicely as I can. It's a bit harder. Okay. Okay, take note of your graph, it cuts at your axis here, not at the x-axis here at the when you split into the 4 quadrants. Okay, so it should look something like this. Sorry, my shape is very ugly because it is not accurate drawing this on my iPad. It should be a bit more spread out. Okay. Yeah. Okay lah. I do my best, but your own graph, you make sure it looks symmetrical and accurate. Okay. So over here, likewise, go down. Okay. Okay, something like this. Alright, then we label our graph. Y equals to 2 cosine 3x minus 1. Okay. Hey wait, sorry, I realized my graph here cuts wrongly. It should cut. Okay, this is a common mistake that a lot of people make as well. Cut here. At the third quadrant, it should cut here. Not at the x-axis here, but cut at this portion at the axis before it goes to the minimum point. Okay. Alright, so this is my first graph of the cosine graph. Next part, I'm drawing this line here. This graph the line. To draw a line, always remember, draw a simple table of values at the side. Okay, table of values, x and y. To draw a straight line, I just need to have 3 points, x and y. Okay, and these 3 points should map out based on my range of the graph. Negative 2 pi over 3, 0, and 2 pi over 3. Okay, then from there you can easily calculate what is the values. Okay, and actually if you were to look at this graph over here, you realize that it should cut at negative 3 when the x value is 0. Okay, when it's 2 pi over 3, it should cut at, let me see, 6 minus, it should be 3 already over here. Okay, so if you note, this is out of the range of the graph, so that means I have to choose values that are within the range possible. So maybe I'll add in more values to help me calculate. Okay, in this case here, if 0 is already the minimum value, I'll choose in other values like, let's say, pi over 6 and pi over 3. Okay, then I calculate what is the possible values. Okay, when I submit pi over 6, this will be 9 divided by 6 minus 3. So this will be 18, negative 18 over 6. Okay, this will be where 3 over 2 minus 6 over 2. This will be negative 3 over 2. Negative 3 over 2. Okay, then likewise, if it's pi over 3, this will be 0. Okay, so therefore the next line, if I plot based on the points I have from my table of values, I get here, here. Okay, and negative 1.5 should lie somewhere here. Okay, so if I draw this line, it should look something like this. Okay, for your line that you draw. Okay, this is the line. Y equals to 9 over pi x minus 3. Okay, so this is for part 1. Part 2, once I've gotten these two lines over here, hence state the number of solutions for this. Take note, we cannot just say 1 because this is not equivalent to what I have over here. We must first manipulate this equation to look like this equation equals to this equation. So we start from what is given, which is cosine 3x equals to 9 over 2 pi x minus 1. Okay, then from here I manipulate this. This will give me cosine 3x plus 1 equals to 9 over 2 pi x. Okay, so therefore 2 cosine 3x plus 2 equals to 9 over pi x. Therefore 2 cosine 3x plus 1 I minus 3 on both sides. Minus 1 equals to 9 pi x minus 3. With this manipulation, I can see that this is the curve, the trigo curve, this is the line. Therefore, only with this workings over here, we can therefore conclude, therefore, one solution. Okay, take note, if you just write one, this will be marked wrong. You must show that this equation here is equivalent to this equation. Therefore, I can use the graph to explain why there is only one solution. Okay? Alright. Let's now move on to question number 14. Okay? Question number 14, prove this identity. We usually start from the more complicated side. So over here, I'll choose left-hand side. Okay, I start with 1 plus cosine x over sine x plus sine x over 1 plus cosine x. Okay. Then from here, okay, we combine the two fractions together. So very simply, this will become 1 plus cosine x the whole thing square over sine x times 1 plus cosine x. Okay, then plus, in this case here, sine square x over sine x times 1 plus cosine x. Okay, therefore, I expand and simplify, I'll get 1 plus 2 cosine square x plus cosine square x plus sine square x. Okay, over sine x times 1 plus cosine x. Then I continue. I know that sine square x plus cosine square x, this is simply equals to 1. So this will become 1 plus 2 cosine square x plus 1 over this denominator here, sine x times 1 plus cosine x. Then from here, this will be 2 plus 2 cosine square x over, sorry, this is not cosine square, this is 2 cosine x. Okay, okay. Therefore, over sine x times 1 plus cosine x. Okay. Therefore, continue to simplify. Factorize out common factor from the numerator. Okay, you will get 1, factorize out 2, then 1 times cosine x over sine x times 1 plus cosine x. And therefore, we can cancel out common factor from the numerator and denominator, which will leave me with 2 over sine x, which is equal to 2 cosecant x. And therefore, this is go to the right hand side, therefore proven. Okay. Alright, then now for part B. Hence, find all the values here. Okay, I know that from this equation here, I can convert the first part here. Over here, I can convert this to become 2 cosecant 2x equals to 4. Okay, take note, this question here is 2x. So I'm changing here, instead of 2x to become, instead of x, this will become 2x. Okay, therefore, this means that cosecant 2x is equal to 2. Therefore, the reciprocal, sine 2x is equal to half. Okay, so therefore over here, this means that alpha is equal to sine inverse half the reference angle, which is pi over 6. Okay, take note, question is in radian. Okay, therefore 2x is equal to, in this case over here, I check the range as well. I'm given that x is between 0 and 2 pi. So therefore, 2x is between 0 and 4 pi. So I know that sine 2x equals to half. This means that x is in first and second quadrant. Okay, so therefore, first quadrant is pi over 6. Second quadrant is pi plus pi minus away pi over 6. Okay, check the range is until 4 pi. So I need to add one more cycle to both my answers. This will be 2 pi plus pi over 6 and 3 pi minus pi over 6. Okay, maybe I'll show the arrow so you can see clearly. Plus 2 pi. okay, plus 2 pi. Okay, therefore, very simply, x, divide all your answers by 2 and simplify. You should get 4 answers. Pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Okay, oops, I did right, over 16 over 12. Okay, and this is for part B. Alright, okay, now last question. Okay, over here, I have a trapezium ABCD. Find the show that the perimeter of this trapezium is given by this expression here. So very simply, all we need to do is to split this diagram into two parts. I have a theta here, 10. So therefore, very clearly, you must recognize that I must be able to split this diagram into two parts. A right-angled triangle over here, okay? And from this right-angled triangle, you can see that this length here would be simply 10 sine theta. This length here would be 10 cosine theta. Okay. So therefore, parameter CD. Okay, I know that CD in this case here is 15 minus 10 cosine theta. Okay, this length here is 15 minus away 10 cosine theta. Okay, so therefore, since parameter is given by the sum of all four sides, which will be 15 plus 10 plus CD is 15 minus 10 cosine theta. Then after that, the BC is equal to 10 sine theta. Simplify everything, you will get 40 minus plus 10 sine theta minus 10 cosine theta. Okay, therefore this is shown for part A. Okay, now moving on to part B. Okay, express P in the form of this. So therefore, I want to turn this expression using the R formula to combine them together. I'll let 10 sine theta minus 10 cosine theta be equals to R sine theta minus alpha. Okay, so by the sine addition formula, I'll get R sine theta cosine alpha minus away R cosine theta sine alpha. Okay, so compare the two terms. First term, 10 sine theta compared to this. Okay, this means that 10 is equal to R cosine alpha, and that's my green, and 10 cosine theta is equal to this case over here, which is 10 equals to R sine alpha. Equation 1, equation 2. So equation 2 divided by equation 1, which will give me tangent alpha equals to 1. Okay, so therefore alpha is equal to tangent inverse 1. Oops, tangent inverse 1, which is 45 degree. R is equal to square root of 10 square plus 10 square equals to square root of 200. Okay, so this can be simplified. Square root 200 can be simplified to become 10 root 2. Therefore, final answer, S, okay, this expression here, P, can be written as 10 root 2 sine theta minus 45 degree plus 40. Okay, take note, this one must be simplified to square root 200. Okay, so if you never simplify here, you lose a mark. So please make sure you simplify all your sets in your final answer. Alright. Okay, and for the last part, okay, given that P is 44, find value of theta when P is equal to 44. Okay, this means that square root 200 sine theta minus 45 degree is equal to plus 40 is equal to 44. This means that sine theta minus 45 degree is equal to 4 over square root 200. Okay, therefore, from here to solve this, simply I know that this angle must lie in the first quadrant. Okay, alpha is equal to sine inverse 4 over square root 200, which will give me 16.430 degree. Therefore, theta minus 45 degree is equal to 16.430 degree. Okay, therefore, theta is equal to 61.4 degree round off to 1 dp. Okay, take note theta is acute, so there is only one possible answer for this. Okay, and with that, we have come to the end of the entire paper. Okay, so hope that you can learn from your mistakes and work on what you need to improve before your final examinations. Alright, we are done.